So here's the new cell sitting on a container that I chopped up and put a hole in so that I can have it standing and have access to the terminals there. And it's surprisingly clean for something that was running yesterday. And a couple of things I want to talk about today is what I see when the cell is charged and it's connected to the scope. You can see this fuzzy line, and once the bottle and the water is full of gas and you start completely disconnected from voltage, and you'll see voltage on the cell, and when you short it out and let go again, it jumps back up from being shorted from that dead short condition, and voltage climbs again. So I started loading up a supercap from the power that was in the cell after being started. And this is something that Maya spoke about, electron extraction, and there's one actual circuit that shows a flip-flop where there's two transistors side by side, and then the base of one that is stealing from the cell the electrons when the gating for the other pulse signal is off. What you see in one of Maya's pulse train signals coming out of, I think it was the 8XA or 9XA or something, there's a function where you get the pulses on the top with an equal pulses in the negative value and then back into the positive. And what I think's going on there is, if it's hooked up to this flip-flop 2 transistor arrangement where the power coming through the VIC delivers into this and then turns off, and that off time has that negative gating, which would, if connected correctly to the gate of the one that now shunts the power back through to a load and then steals power out, then it's a pulse the cell, steal from the cell, pulse the cell, steal from the cell. And I can show you rudimentary just charge through the power here. We'll hook it up to the scope, and when I short the cell like that, you'll see it goes to 0 voltage, and then I'll let go and it'll climb back up again. And it's, you'll see what I'm talking about. Hang on a sec. Okay, the cell is hooked up to the oscilloscope there, and there's the line. So I've got a little watt meter here. There's 12 volts. There's a 3 amp 12 volt power supply there feeding this little watt meter, and so we'll get a baseline for Faraday electrolysis on this cell from here, and once it's charged I'll show you the discharge. So I'll just pause and hook this up. Okay, so once I connect that into there, the cell will liven up. I'll just do that now, and so you can watch it wake up. It's always nice to see the cell start from scratch. Okay, power's on. It's 0.3 of an amp. Look at the way it's pulsing. That's tap water, no electrolytes. Yes, I'm aware that there's ions in tap water. Okay, so there we are. So 0.3 of an amp that runs at. So I need to be able to do better than that, better than 3.7 watts using a Stanley Meyer method. But okay, so where's our baseline gone? It's gone climbing because the cell is charged. So we'll just disconnect that out of there. So what we've got there is the cell. Come on, show us the fuzzy line. Maybe that's not connected properly. So I'll short the cell now. And see, it just jumps straight back up. I'm now just pulsing it like tap, 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 tap. If I go really fast, it actually starts to look like a step charge. And now it's back to front, and we're stealing voltage from the cell here. We're at 500 millivolts per division, so that's about half a volt jumping up and down. But if we take that half a volt and put it straight to the supercap, well, we can start taking electricity away from the cell and have a usable source. So perhaps that's a method to think about, setting up a switching. It could be like a double pole relay that flicks to the cell and then dumps to the cap, and that could steal in an electron extraction sort of setup with complete disconnect, which is always a good thing when you're trying to create these jumps and spikes. Anyway, that's where I'm at. I thought I'd just share that, and thanks for watching. Don't forget to thumbs up if you like the content, and subscribe if you haven't already. Oh yeah, it was what I was mucking about with, an idea here of, there's a VIC described in some drawings I saw that had the windings of this set up in such a way that the primary wasn't on the inside and then the secondary was on the outside, but I should be able to go the other way. I know it'll change the behaviour of the thing, but if I put those two on there and center tap these two together, then wind a primary, like a Tesla bifilar primary, over both of these, and then drive it from another transformer, which is the description of the two-part VIC, which is seen in both descriptions when you go looking for Stan's thing. Anyway, that's where I'm at. Thanks. Cheers.